Okay, welcome back to math class. You may remember yesterday we talked about factoring, prime factorization, what it means to factor monomials and rewrite them as products of their factors. Today we're going to talk about what happens when we multiply and divide multiple monomials together. To start out, I just want to say, anytime you multiply a power that has the same base, you add their exponents together. So what that looks like is like if I had 4 to the third times 4 to the second. You see these are powers that have the same base of 4. I'm multiplying them together. Basically what I'm saying here is 4 to the third is 4 times 4 times 4, right? And 4 to the second is 4 times 4, right? So when I'm saying 4 to the third times 4 to the second, what I'm actually saying is 4 to the fifth. 5 4s multiplied by each other. And if you notice, 4 to the fifth is the same as 4 raised to the 3 times 2. 3 plus 2. So anytime you multiply powers that have the same base, you just add the exponents and you get your new power. That still goes if I am multiplying variables or if I'm multiplying variables with coefficients. So let's practice one. If I have 8 times x squared times 3 times x to the fourth, like this. What I'm going to do with this is I'm going to break it down into its pieces. I have 8 and 3 as my coefficients. So I'm going to go ahead and write those out as 8 times 3, right? Now I have x squared, which is x times x, and x to the fourth, which is x times x times x times x. So I had x squared and x to the fourth. Now all I do is multiply it out. I have 8 times 3, which is 24. And I have 1, 2, 3, 4, 5, 6 x's. So my answer is 24 times x to the 6th. Now if I didn't want to write out all of these x's right here, I could have rewritten this as 8 times 3 times x to the 2 plus 4. And I'm going to get the same answer. 8 times 3 is still 24. X to the 6th. So anytime I'm multiplying with the same base, powers with the same base, I just add their exponents. Now, like you might imagine, if instead of multiplying, I'm dividing, I'm going to do the opposite, because division is the opposite of multiplication. Right? You guys know that. So if I'm dividing, say I have a to the fifth divided by a to the second. Now you guys remember a fraction is the same as dividing. This stands for a to the fifth divided by a to the second. All I'm going to do is the opposite of what I did before. Basically what I'm saying here, well, let's write it out. A to the fifth is going to be a times a times a times a times a, 5 times. A to the second is going to be a times a. Now as I'm dividing, simplifying this fraction, a divided by a is 1. Those guys are going to cancel out. A divided by a is 1. They're going to cancel out. And what I'm left with here is 3/8. A to the third. Now you'll notice a to the third is the same as if I took this a to the 5th minus 2. And I just subtracted their exponents, also gives me a to the 3rd. So anytime I'm dividing an exponent, I just subtract. I'm dividing a power, I subtract their exponents. Good?